Hi everyone, in this video I will discuss the famous interview problem odd even linked list. So we are given the head of a singly linked list. We need to group all the nodes with odd indices together, followed by nodes which have even indices, and return the reordered list. So the first node in the linked list is considered odd and the next node is considered even, and the sequence continues. Let's take an example. So we are given this linked list. So the first node, which is A here, so this will be odd, then B is even, C is again odd, D is even, and E is odd. So we need to first group all the nodes which have odd indices, so which are node A, then we have C, and then we have E, and followed by nodes with even indices, so which are B and D. So we need to return this list. Also, when we are returning the reordered list, we need to maintain the sequence, which means in the odd nodes, which are A, C, E, so these occur in the same order as in the original list, and B, D, which are even, so these are also in the same order as were in the original list. So we need to maintain the sequence in odd and even list. Let's take one more example. So now in the second linked list, A is odd, then Z is even, D is odd, R is even, E is odd, and X is even. So the odd nodes are A, D, and E, and the even nodes are Z, R, and X. So this will be our answer. So first group all the odd nodes and then group all the even nodes and then join them together. So this will be our reordered list. Now once we've understood the problem statement, let's see how we can solve this. So basically we'll take two pointer approach. One pointer will contain the linked list which has nodes with odd indices, and the second pointer will track the nodes which has even indices. So the odd nodes are A, D, and E, and the even nodes are Z, R, and X. So for the even nodes, we also need a pointer to the head of the linked list. And for the odd node, we need a pointer to the last node of the linked list. So this is the first node, and E is the last node for the odd linked list. So if we connect the last node of the odd linked list to the first node of the even linked list, then that will give us the solution. So we'll follow this approach here, that will keep track of two pointers, odd and even, and we'll also keep a pointer to the head of the even linked list. So once we have both of the linked list separately, then we can join the last node of the odd linked list to the head of the node of the even linked list. Now let's see the algorithm for this. So we'll keep a pointer odd which is pointing to the head of the linked list. So odd is pointing to A. Then we'll keep two pointers, even head and even. Both are pointing to the first node of the even linked list, which will be second node of the linked list. So even head will point to Z. Then we run a while loop till even is not equal to null and even next is not equal to null. So in the first step in the while loop, we set odd next to odd next next. So odd is at A. So odd next means next of A becomes D. So we set the pointer from A to D. And then we change even next to even next next. So next of Z becomes R. So this link breaks and this link breaks. Then we move odd to odd next. So odd comes at D and even comes at even next. So even comes at R. In the next iteration, we set odd next to odd next next. Odd is at D. So next of D is E. So next of D points to E. So this link breaks and we set next of even to even next next. So even is at R. So even next next is at X. So next of R is set to X. Then we move odd to odd next. So odd comes at E, and we move even to even next. So even comes at X. So in the next iteration of while loop, we check if even is not equal to null and even next is not equal to null. So even is at X. So next of X is null. So now the while loop terminates. So now if we draw these linked list again, so the first linked list, which is odd, so that is starting from A, then we have D, then we have E. And the even linked list is Z, then we have R, and then we have X. So the even pointer is at X and the odd pointer is at E. And when we initially started, we set an even head pointer also, which was pointing to Z. So we have an even head pointer, which is starting of the even linked list. So that is pointing to Z. Now we have separated the list which have odd indices and which have even indices. Now we need to join them. So to join them, what we are doing is we are setting next of odd to even head. So odd is at E. So next of E is set to Z. Because even head is pointing to Z, so next of E becomes Z. And then we return the pointer to head of the linked list. So head of the linked list is pointing to A. So the final linked list which we are returning is A, D, E, Z, R, X. So we have grouped together the nodes with odd indices and even indices and returning the reordered list. If we talk about the space complexity here, the space complexity is order of 1 because we are not using an extra space, and the time complexity is order of n, where n is the length of the linked list because we are traversing all the nodes only once. Now once we've understood the algorithm for this, let's have a look at the implementation. All the source code that I'll be showing is available in my GitHub repository, link of which is present here and as well as in the description. Now let's have a look at the code. So in the main function, first I create both the linked list which I've shown on the left side. So the first linked list is ABCDE and the second linked list is AZDREX. Next I pass head of this linked list to this function odd even list. In this function, first I check if the head is null. So that means there is no linked list to traverse, so I return the head of the linked list. Otherwise I create 3 pointers. Odd is pointing to the first node of the linked list. Even and even head both are pointing to the second node of the linked list. Then I have this while loop to traverse the linked list. I traverse until even is not equal to null and even next is not equal to null. In each iteration, I set odd next to odd next and even next to even next. And then I move odd and even to the next nodes. So after the while loop ends, I have two linked lists. One has all the odd indices and the second list has all the even indices. To join them together, I set odd next to even head and then I return the head of the linked list. And in the main function, I print the linked list from the head. Let's see the output of this program. So the first linked list is ABCDE. The linked list after reordering is ACEBD. Second linked list is AZDREX and the linked list 2 after reordering is ADEZRX. Now this problem is also available on LeetCode as question number 328 odd even linked list. I have pasted the same code here and it is success. So that was all for this video. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.